So looking at solving Euler's method, it'll give you three basic important pieces of information, or four. It'll tell you what to approximate. In this scenario, we're looking for f of 3. It'll also tell you the initial condition, which in this case is f of 1 equals 0, the step size, which is 1, and the differential equation that we'll be using. In this case, it's x minus y. The best way to approach these types of problems is to draw a chart. So we have here the x value, the y value, and the change in x times the slope, which is going to equal your change in y. Looking at all the information we have, we know that our initial condition is f of 1 equals 0. So you're going to put 1 here, 0 here, and we're looking to get to f of 3. So that's going to be our final. With the step size of 1, we know that the x is going to be changing 1 each time. Step size is the same as your change in x. So we have from 1 to 3 to get a step size of 1, there's a 2. So the first thing that we're going to plug in is the change in x. Now the change in x is the same the entire problem. In this case, it is 1. And our slope, in case you don't remember, your differential equation is equal to the slope. So in this case, it's x minus y, and we have 1 minus 0. So multiplying all this together, you have 1 times 1 minus 0, which is 1. So your change in y is 1. What you do here then is carry that over, so 0 plus 1, and your new y value is 1. So now you repeat the same process again. Your change in x is still 1. Now your slope is, since it's x minus 2, is going to be 2 minus 1, which is again still 1, and that is your new change in y. So over here you have 1 plus 1, which will equal 2, and this is just our final answer. So this next example is phrased in a manner very similar to how it will be phrased on an AP exam. It says, let y equals f of x be a particular solution to the differential equation dy over dx equals x times y. So there's our slope with the initial condition of f of 0 equals 2. And another thing to note is that AP problems will always state that you are to be using Euler's method if you need to be using, or Euler's method if you need to be using Euler's method. So it says use Euler's method and 2 steps of equal size to approximate f of 1. So we know that we're trying to reach f of 1, but it says that we have to use 2 steps of equal size. Well, if we know we're starting at 0, we know we're ending at 1, the only way to get 2 steps of equal size is to have it be a change in x of 0.5 or half. So looking at this, with the initial condition of f of 0 equals 2, we can put the 2 in the y column and then start filling in the rest of the table. So our change in x is always the same. It's 0.5. And our slope, in this case, is x times y. So 0 times 2, which is 0, making the change in y 0 as well. So 2 plus 0 still equals 2. And we're going to keep going the same way again. 0.5 times x times y. Sorry, this should be 0.5 times 2. So 0.5 times 2 is 1. 1 times 0.5 is 0.5. This is our new change in y, so we know that we have to do 2 plus 0.5, and our answer is going to be 2.5.